How does specific heat capacity affect material temperature? Imagine you're heating a pot of water and a piece of metal at the same time. Why does the water take longer to warm up than the metal? The secret lies in something called specific heat capacity. This property tells us how much heat energy is needed to raise the temperature of a certain amount of material by 1 degree Celsius or Kelvin. It's like the material's ability to store thermal energy. When you add heat, the temperature of the material changes depending on its specific heat capacity. If a material has a high specific heat capacity, it needs more heat to increase its temperature. That means it heats up slowly because it absorbs a lot of energy without changing temperature much. Metals like iron or copper have low specific heat capacities, so they heat up quickly because they don't need much energy to raise their temperature. Water, on the other hand, has a high specific heat capacity, so it takes a lot of heat to warm up, but it also cools down slowly. This property is described mathematically by the formula Q equals m times c times delta T. Here, Q is the heat energy added or removed, m is the mass, c is the specific heat capacity, and delta T is the change in temperature. Rearranged, it shows that delta T equals Q divided by m times c. So, for the same amount of heat and the same mass, a larger specific heat capacity results in a smaller temperature change. This is why water's temperature changes slowly when heated or cooled. Specific heat capacity is an intrinsic property, meaning it depends on the material itself, not how much of it you have or its shape. For example, water's high specific heat capacity makes it excellent for regulating temperature in nature and in heating systems. Metals with low specific heat capacities heat up quickly, making them ideal for cooking pans. In thermodynamics, this property reflects how a material stores thermal energy and relates to internal energy changes as temperature varies. There are two common types of specific heat capacity: at constant pressure and at constant volume. For solids and liquids, these values are often similar because volume changes are small when temperature changes. Understanding specific heat capacity helps in designing systems for heating, cooling, and energy storage. It explains why some materials are better for storing heat or for quick heating applications. In climate science, water's high specific heat capacity helps stabilize Earth's temperature by absorbing and releasing heat slowly. To sum up, the higher the specific heat capacity of a material, the slower its temperature will change when heat is added or taken away. It's a key property that influences how materials respond to thermal energy, making it essential in both everyday life and scientific applications.